Hello, my name is Jailer D. Bustamante from DICT 1, and here's my reflection video for the ICT webinar. The research speaker, which is Mr. Dennis Zapanta, Espiritu CPE MIT, executed the topic with clear speech and confidence, explained the advantages of an Arduino, a brief history of it, and even tackled different kinds of and parts of an Arduino. The most part that caught my interest was on sensor modules that amazed me and realized how many possibilities that you can make using those things to the Arduino. There is another kind of Arduino that caught my attention, and that was the Gizduino. It was made in the Philippines and was quite shocked that they have developed the prototype and felt proud for a second. It also made me think that why did the prototype why did not recommend these products locally, but instead recommend other brands. This also leads me to another question, that maybe international brands may be less expensive than our prototype. The Arduino was made to help students to build interactive designs, and that is less expensive than other prototyping systems. The founders are Massimo Banzi and David Quartieles. They named it after Arduino of Ivrea, and began producing boards in a small factory located in Ivrea, Italy. The Arduino can be programmed with the use of Arduino software IDE. Arduino IDE works on any kind of OS you are using, like Windows, Linux, as well as Mac OS. Arduino Uno can be easily programmable and low power consumption. It operates using 5 volts and 3.3 volts input voltage, recommends 7 to 12 volts, have 6 pins of analog input, and a clock speed of 16 MHz. The most popular Arduino boards that are used more are Arduino Uno, Arduino Leonardo, Arduino Mega, Arduino Duo, Arduino Micro, and Arduino Lilipad. These Arduinos are made depending on the project you are making or developing. Arduino Lilipad is a circle-shaped Arduino made for smaller projects, and surprisingly, they are washable. It can also be used in clothes. Arduino Duo is the first Arduino board based on a 32-bit ARM core microcontroller with 54 digital input-output pins and 12 analog inputs, 2 digital to analog converter, and 2 control area network. It is the perfect board for powerful larger scale Arduino projects. There are other prototype platforms that challenges the Arduino, and these are Raspberry Pi, BeagleBoard, PandaBoard, Intel Galileo, and Gizduino. Raspberry Pi was made in US, BeagleBoard made in China, Intel Galileo made in Finland, and Gizduino made in the Philippines. These are the sensor modules that was mentioned in the seminar: ultrasonic module sensor, soil moisture sensor, microphone sensor, photoresistor sensor, temperature sensor, rain detection sensor, passive buzzing module, speed sensor module, flame detection sensor, and many more. I will discuss some module sensors. The ultrasonic module, or the sensor, measures the distance of a target by emitting ultrasonic sound waves and converts the reflected sound into an electrical signal. The soil moisture sensor: a small charge is placed on electrodes and electrical resistance through the sensor is measured. As water is used by plants, or as the soil moisture decreases, water is drawn from the sensor and resistance decreases. Conversely, as soil moisture increases, resistance decreases. A microphone sensor or transducer, which converts sounds to electrical signals when the moving plate vibrates in time with the sound wave. The distance between the plates, and hence the capacitance is changed. The changes in capacitance can be converted to an electrical signal. These module sensors inspired and caught my interest more in Arduino. I really want to try all of these module sensors to the test and experiment more and try different ideas that come out of my mind. He also discussed a simulator that is Tinkercad. This is also the simulator recommended by our professor when experimenting ideas. He also discusses Arduino terminology that are sketch, pin, digital, and analog. Overall, I have understood every topic that was discussed and learned to make it in the simulator called Tinkercad. He did tell Ohm's law and its relation between voltage, current, and resistance, learned codes and more using the Arduino Uno that is being used in our robotics subject that is quite handful for our future projects. It can be a testing ground for programming and coding my sensor modules and preventing explosion or some malfunctions. It can also prevent me from buying more if I damage my parts in making a project. Overall, the topic was really enjoyable, and thank you for Sir Dennis for explaining what are Arduino and its functions and types, and especially to Sir Deepa in giving permission to join in this webinar. I am thankful for you that is watching this video of my reflection video in the topic Arduino. If you did not watch my PLC reflection video, please watch it on this channel and hope that you enjoy and maybe you will be inspired and testing out an Arduino on your own, and recommend to use the Tinkercad for testing ideas you want. Again, thank you for watching.